right, welcome back. So in this video, I'm going to do problem 52 for you. So here we have Creative Sports Design manufactures a standard size and an oversized racket. So I'm going to let S stand for the standard size racket, and I'll let O stand in for the oversized racket. And what do we want to do? How many rackets of each type should CSD manufacture over the next 2 weeks to maximize the total profit contribution? All right. Well, thankfully, this problem, they give us the total contribution per racket. So what I want to do, so my objective function, right, is going to be to maximize the $10 in profit that the firm gets for every standard racket, plus the $15 in profit the firm gets for every oversized racket, right? So easy, right? There is our objective function. And then we've got to subject that to constraints. Well, in this case, we're going to have 3 constraints. So the first constraint is the alloy, right? And according to this, the standard racket uses 0.125 kilograms of this alloy, and the oversize uses 0.4 kilograms. And then, of course, over the next 2 weeks, they only have 80 kilograms. So, you know, right, that's got to be less than or equal to the 80 kilograms that I have. And then I have my manufacturing time. And the standard racket uses 10 minutes, so that's 10 minutes. That's 10 minutes for the standard racket, plus 12 minutes for the oversize, right? And that's got to be less than or equal to, well, I have 40 hours are available per week. So I want to do this over 2 weeks. So, and then I want to convert, because these are in minutes, right? This is 10 minutes, 12 minutes. So what I want to do is I want to convert the 40 hours to minutes. So 40 times 60, that gives me 2,400 minutes per week. And then, of course, I multiply that by 2. That gives me 4,800 minutes over the 2-week period. So this manufacturing constraint should be 10S plus 12O less than or equal to, what I say, 4,800. All right? And then the last constraint. Management specified that at least 20% of the total production must be the standard size racket. Okay, so this is a constraint similar to the one in question 50. Okay, so what management said is they said, I got to read it again. 20% of the total production must be the standard size. So what they're saying is that S must be greater than or equal to 20% of the total production. Well, that is simply S plus O. So therefore, S is greater than or equal to 0.2. That's an S, not a 5. Oh, rats. That's an S plus 0.20. Move everything over. I think I've said this before, but you can't have your choice variables on the right-hand side of the constraint. So I want to move these suckers over. So that means I have 0.8S minus 0.20 greater than or equal to 0. All right? So that is my third and final constraint. So I'm going to put that in here, 0.8S minus 0.20 has to be greater than or equal to 0. And then, of course, yes, I do have my non-negativity constraint. So S comma O has to be greater than or equal to 0. All right? So there is my problem. All right? And then what I'm going to do is, I apologize for this, but I'm going to erase. Erase. There we go. Sorry, I'm going to erase this just that I have some room to write out the problem in Excel. Okay, so we are now ready to go. So here is, here's my S. Actually, I'm going to move that, delete. Here is S. I don't know why I did that. O. Okay, here are my parameters. Choice variables. Objective function. Okay. Okay, so here's 10, 15, 1 and 1. And of course my objective function is always some product. I bet you're tired of hearing that. So parameters, one array, choice variables, the other array, hit OK. Now let me just shorten this up a little bit. Okay. Constraints, I have 3. Okay, so constraint 1, 0.125, 0.4. That looks like I need to make this bigger. There we go. Okay. Second constraint, 10, 12, 0.8, negative 0.2. Whoa, hey. All right. Oh my gosh. There we go. Okay. Less than or equal to. Less than or equal to. Greater than or equal to. So let me make this smaller. 80. Whoa. 4,800. 0. Okay. All right, so then real quick, I'll do my sum product. Okay. Choice variable, array 1, array 2 are the parameters of the constraints. Hit OK. Anchor the choice variables. Copy down. Shorten so I can get everything on one screen. Rats, not good enough. Yeah, oh well. Okay. Nonetheless, here I've got everything set up in Excel. I'm now ready to solve. So I will go to Data, Solver. Okay, so what am I going to do? I want to maximize that function by changing my choice variables subject to the constraints that these two values are less than or equal to these two values, and this value is greater than or equal to this value. All right, I've got my check this box for my non-negativity constraints, simplex LP, solve, voila. Okay, so in order for this firm to maximize its profit, it should produce 300 and, oh, sorry, let me go up one. Come on. There you go. That's too far. Ah, that's ridiculous. Okay, sorry. This firm should produce 384 standard size rackets, 80 oversized rackets. If it does that, it will make a profit of $5,040, and that is the most it can do given these constraints. All right, so there you go. Problem 52. Hang in there. 2 more homework videos to go, and you'll be done for the week.